Part 2 to that question, calculate the tension and acceleration of the system if the coefficient of friction is a half for the two of those. Just as a reminder, the diagram is there, 6 kg on the plane, 3 kg off the plane. Now the friction only applies to the plane, so the formula for this remains the same. And to go through it again, if it's got a mass, it's got a weight. If there's a string connected to it, there's going to be a tension acting away from the particle, and we know the acceleration is down. In this case, the acceleration is to the right then, and let's go through our checklist of forces. If it's got a mass, it's got a weight, 6 by 9.8. There's a tension because there's a string. It's resting on a plane, so the plane pushes back. Let's call it N in this case. And friction always opposes the motion, so we'll have friction acting that way. All right. We have perpendicular forces here. We need to look at those separately. So there's the plane. We're going to look perpendicular to the plane, keep those together. Parallel to the plane, keep those together. Now, perpendicular to the plane, there's no acceleration, so we can pick whichever way we want to be positive. So N plus N minus 6g is a mass times 0 vertical acceleration. In other words, the particle isn't going to accelerate off the plane, and it's not going to accelerate into the plane. So I get that. Let's have a look at parallel to the plane. So parallel to the plane is the horizontal direction. It's going to the right, so the right is positive, the left is negative. And we end up with plus T minus F is equal to the mass multiplied by A. All right, we're almost there. The thing to remember here is if the object is on the point of slipping, the friction force can be calculated by the coefficient of friction, which is the roughness of the two surfaces in contact, multiplied by the reaction force. That's an N value there. And that N is how much the particle is pushing into the plane, or at least related to it. So my friction force there is a half of, and I can take the N there, 6g, which gives me 3g in total. So that formula now becomes T minus 3g is equal to 6a. And what we need to do is solve the two of those. So I leave you solve the two simultaneous equations there for T and F. The rest should be fairly straightforward.